Okay, here's another application of that distance formula, right? So at this point, if you haven't watched the first video, you should be going back to that. So here's another example, right? So find the area of the triangle with vertices at 3, 4, -1, 5, and 1, -6. Okay, so this is our question here. We're going to find the area of this triangle. We have a couple different options we've used this year for how to do this one. Right? We could find the lengths and use trig and whatever to do that. But here's just another option we can have. We can use vectors to do it. We just did it with vectors in the last unit. Right? So a couple different ways to do it. But let me just show you how we could use it. How we can assign. We can do this with our with this new. What we have here with distance. Okay, I'm just going to call those A, B, and C, right? Doesn't really matter. So if I'm thinking about it, let me find the distance from A to B, right? And the distance from A to B, I can see is, let's see, so that's 4 spaces, so 4 squared, and that's 1 space. So that's root 17 there. Okay, so A to B is root 17. Okay, now if I can figure out how far apart this point is from that line, right? So, right. If I find how far is C from AB, then this is going to be, right, that's the height. That's the height of this. So this would be the base, and this is right here is going to be my height of the triangle. Okay, I'm going to have enough information to solve this. Okay, so there's my point. If I get this equation of AB, line AB, and so let's see, my slope there, right, is going to be rise 5 minus 4 is 1, right, -1 minus 3, -4, so there's my slope there, -4. The equation, I'll pick this point, so y minus 4 equals -1/4 x minus 3, and then I'll put it into general form, so I'll multiply everything by 4. Actually, multiply by -4, just so I don't have a negative sign there. And that's going to make that. Okay, I'll move this over. So I'll have x plus 4y minus 19 equaling 0. Okay, and then I can find my distance. So, right, my coefficients are 1 times, and remember, we're finding from AB to C, so 1 times 1 plus 4 times -6 minus 19, that entire thing, over a squared plus b squared, right? 1 and 4. So that's 17, but we already knew that because we just did that. Okay, so 1, let's see, this is -24. So, right, -24 minus 19 is -43, right? Plus 1 is -42. So it's going to be 42 over root 17. Don't bother to rationalize. That's my height for the triangle. That's my base right there. And so 1/2 base times height. So I get 21. Okay. Hey, look, this and that matched each other because we had that. So really, we do have a shortened version for ourselves. So, right, what's the takeaway here? That the area of a triangle equals 1/2, and it's really because these two pieces canceled, because this piece canceled that piece for myself. Sorry, I was off the screen there for a second. Right, the area of the triangle is 1/2. It's really just 1/2 that numerator there. So ax of 0 plus b y sub 0 plus c. Okay, so to be the next time we would do this problem, we could say, okay, just get the equation, pick 2 points, right? Get the equation for that, and then use the third point and put it right in there, and that's all you have to do for it. Okay, so just to illustrate that, to make sure I'm being crystal clear, right? Example 4 here, right? Find the area of the triangle with vertices of, I don't know, let's make up some random points here, right? So let's call it like 3, 10, right? 5, -2, and -6, -8, right? If those are my 3 random points, okay? You pick 2 of them. So I'll use A, B, and C. So I'll do the line between the first two, right? So line AB has a slope of, let's see, 10 minus negative 2 is 12. 3 minus 5 is negative 2, so my slope is negative 6. My equation then would be y minus 10 equals negative 6, x minus 3. All right, distribute. So there's the equation of my line, and I need it to be, so the area is going to be 1/2, right, 6 times negative 6 plus 1 times negative 8 minus 28. Okay, negative 36 minus 8 is negative 44, right? Minus 28 is negative 72, positive 72, so it's 36. Right, as our area. Okay, so you can see that of all the different ways we've done, right? If I didn't have a calculator, man, that looks like the easiest way to do it. Definitely, right? I don't do any inverse trig for it, so I'm going to use that as much as I can, right, for myself. Okay. So, right, those are a couple examples. Now, one other application that we'd have right here, okay, for ourselves. So let's say we have two lines for myself, okay? Two intersecting lines. And I want the equations of the angle bisectors. Where would our angle bisectors be? Right here and right here. Okay? Okay, now what you may or may not remember back from geometry, right? And this is one of those theorems that we did back then, right? That you not everybody remembers, but right, it is important to remember that. Sorry, I'm just trying to get everything set. Okay, there we go. Right, that the angle bisectors, right, are the set of all points equidistant from two lines. Okay, and that was our angle bisector theorem that you did back in geometry days. Okay, all right. Angle bisector theorem said if you have an angle bisector, it is equidistant from the two lines for all points. Okay. So let's call this line right here A1x plus B1y plus c equals 0, and we'll call this one here A2x plus B2y plus c2 equals 0. Oh, I got my one there. Okay. And let's call this point anything we want it to be. Let's just call this point x comma y, right? Because we don't want to keep it. We don't want to put a subscript on it because that would say it's got coordinates. We just want it to be general. Okay. So the distance from this to this, right? That would be from this blue line to this one would be a1x plus b1y plus c1. Okay, and that has to be equal to a2x plus b2y plus c2 over a sub 2 squared plus b sub 2 squared. Okay, I forgot my subscripts there. I'll go back and put those on. All right, for those ones. Okay. So we need those two to be equal for ourselves. There we go. Now you can see the equation. Okay. Right, and that's just, hey, look at these two equations. These are the two distance equations. We know the distance have to be equal. Okay. So for my answer, right? My answer for this, because we want to have equations, and the equations we may or may not decide to put it into standard form. It's kind of nasty if you put it in standard form, but it's doable, but it can be kind of nasty to work, right? Is since we have the absolute value bars here, we have to consider the two cases. One of the cases is that these groups are going to be the same. They're either both positive or both negative. In that case, the absolute value bars aren't really doing anything. If these are both positive, then the absolute value bars are meaningless. If they're both negative, then the negatives will cancel each other out from each other and make it back into the positive case. But if one's positive and one's negative, right, or it doesn't matter which one's positive or one negative, then we're going to have opposite signs, right? So your equations are going to be, right, a1x plus b1c1. We want to try it right without the absolute value bar, so we could actually simplify this, right? And what you just pick one of the two sides and you put a plus or minus in front. And all that's saying is that you either have the groups on the inside to be the same sign or the opposite sign. The plus represents the two groups being the same sign, the minus representing the two groups being the opposite sign there. Okay? Right, and so this is the equation of your angle bisectors for yourself. Right, that's how you could actually find it pretty quickly. Okay, so as you go through and you do the book problems for this section, good luck with those. Let me know if there's any problems you need me to go through, and I'll make a video, explain it, or we can do a Google Meet if you need to. All right, just let me know how you're doing and what you need to help make sure you understand this topic.